Today's lesson is from 3.9 in the book. We're going over Pythagorean's theorem, or the Pythagorean theorem. And what the Pythagorean theorem does is it tells us the length of a diagonal. Just to show you on a map how this might work is I live in Dalton and I work in Columbus. If I were to take the roads, I would have to go straight south to Marcelin area, straight east to Randolph, and then straight south basically to Columbus. To make that a little bit easier, instead of going down and then over, let's just say that I could take some roads straight east from Dalton, and then I could follow 73 straight south all the way there. So I wouldn't have to go south then east. I would just go straight east. I'm going to get rid of that. That would make it easier, so I'd only have to make one turn instead of 3 or 4. Now, that is the entire distance that I have to travel by road, because the roads run east and west, north and south. But if I could find a road or jump on an all-terrain vehicle and go straight to Columbus, that would significantly cut down time and also the amount that I would travel. What you see is that the east-west lane and the north-south road form a right angle, and the diagonal is across from that. What we're trying to do is, if we can find this east and west road, the length of it, and the length of this east and west road, we can use those to find the length of this diagonal. The Pythagorean theorem can only be used with right triangles, and what it tells us is that if we square the legs and add them to make the sum, that should be equal to the square of the hypotenuse. So we call the legs that make up the right angle A and B, and then the side that is across from the right angle, that is the hypotenuse C. A little proof that shows you how this works: if I have a triangle with a length A, and A is 4 in this case, you can see 4 units, and I square it, that's 4 by 4, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units large. Then I take the other leg, because this would be my right angle, and that is 3 units long, so I square that. 3 by 3 is 9. That should be equal to, so I have 16 right there, 9 right there. Their sum should be equal to the C's squared's unit. So C would be 1, 2, 3, 4, 5 units long. 5 by 5 is 5 squared, which is 25. And what you see is that 16 plus 9 is equal to 25. So that's how it works. Now I'm going to show you how to solve for it. We name the legs A and B, and then the hypotenuse C. So it's always A squared plus B squared equals C squared. In place of A, we're going to put 9, so that's 9 squared, plus in place of B is 12 squared, and that equals C squared, because we don't know what C is. Now 9 squared is 81. Always simplify the squares first. 12 squared is 144. That still equals C squared. Simplify this by adding 81 and 144. And you get 225. And then the last step is to always take the square, because the square root, because you have to do that to get rid of that square. So take the square root of both sides, and the square root is 15. So side C is 15 centimeters long. That is when we're solving for the hypotenuse, or C. When we're solving for b, it's a little bit different. So we still have our a side, our b side, and our c side. We say a squared plus b squared equals c squared. A is 3. B squared, we'll just leave alone. And then c squared is 5 squared. Now we're going to simplify the squares first. So we have 9 plus b squared equals 25. Subtract 9 from both sides. And let me get rid of that. That cancels, and I have b squared equals 16. Last step, take the square root of both sides, and b equals 4. So these two sides should always be less than the long side. The side that is across from the right angle, that's the hypotenuse, that should always be the longest side. And if what you solve for b or a is not, then you need to redo that. We're going to solve for y. What we see right away is that the right angle's here. Across from it, that is the hypotenuse, so that's our c side. And then these two can be a or b, it really doesn't matter. So I'll just call this a right here, and this one b. And we have a squared plus b squared equals c squared. A we call y, so we'll just call it y squared. Plus b is 2.5 squared equals c, which is 10 squared. Now 2.5 squared is 6.25, and then we still have this y squared. What I'm going to do is subtract 6.25 from both sides, so it cancels off, and I have to move over. Y squared equals 100 minus 6.25, which is 93.75. Take the square root of both of those, and you get y equals 9.68 centimeters. Find the height from the top of the ladder to the ground. So we know in this triangle, and let me make this a little bit, let's see if red, it's a little bit bigger. We know that this side and this side of this triangle form a right angle. And we know that this side of the triangle is 16 feet because it's the same as the horizontal bottom. And what we know is this is 10. So what we have to do is solve for this part of the height. We'll call that x for right now because we don't know it. And then we're looking at it and we say this is across from the right angle, so this is our c side, and then this can be a and b. Coming down here, we still set it up the same way. A squared plus b squared equals c squared. A is unknown x, b is 16, and c is 30. So moving to the next slide, because it basically shows you the same thing. Call that x. So we had x squared plus 16 squared equals 30 squared. $16 squared is 256. 30 squared is 900. Subtract 256 from both sides, and we get x squared equals 644. Square root both sides, and you get 25.37 feet. Now, if I want to find the whole length, I need to add that 10 feet on to the 25.37, and I get the whole length or height of 35.37 feet. Lastly, can the given lengths be the sides of the right triangle? So we know in a squared plus b squared equals c squared. C always has to be the largest side, and then the other two, the shorter ones, have to be a and b. So let's plug it in and see if it is equal. 5 squared plus 12 squared equals 13 squared. If this is true, then they can form a right triangle. If it isn't, then they can't. So 5 squared is 25, plus 12 squared, 144, equals 13 squared, 169. 25 plus 144 is 169, which equals the other side, 169. So yes. Now let's do the same thing with this. We're going to have our A, our B, and our C, because 12 is the longest. So we have 7 squared plus 9 squared equals 12 squared. 7 squared, 49, plus 81 equals 144. And 49 plus 81 is actually 130, which does not equal 144. So, no, these side lengths cannot form a right triangle. And that is it. Good luck with your homework.